Okay, so let's take a look at Chapter 4, Lesson 1, Classifying Triangles for Geometry. Our objectives for today are to learn about how to classify triangles by their angle measures and side lengths, as well as using triangle classification to find angle measures and side lengths. Our vocabulary is acute, equiangular, right, obtuse, equilateral, isosceles, and scalene. Recall that a triangle is represented by this symbol here and is a polygon with three sides. Triangles can be classified in two ways, by their angle measures and by their side measures, and that's what we're going to look at. Here you can see that we have a triangle that's labeled with A, B, and C. Side AB, side BC, and side AC are all the sides that make up the triangle. A, B, and C are considered the triangle's vertices. We're going to talk a little bit about classification by angle measures. An acute triangle has three acute angles, so as you can see that all three angles are less than 90. Equiangular triangle has three congruent acute angles, so all three angles are the same. They're represented with the arced lines here so that you can see that all three are congruent. And a right triangle has one right angle in it. An obtuse triangle has one obtuse angle in its triangle. So when we look at examples of how to classify triangles with angle measures, what we're given here is to classify the triangle BDC. So we're going to look at BDC in terms of a triangle. So we're given some information here, and we can see that we have a right angle here at D. We have angle A is 80 degrees. This angle D is 20 degrees, and this angle is 10 degrees here for angle C. We can see that angle B is an obtuse angle, 100 degrees. We can see that angle B is an obtuse angle, so triangle BDC is an obtuse triangle because it has at least one angle that is greater than 90. We can look at the same triangle here and understand that angle ABD and CBD form a linear pair, so they are supplementary angles. So, knowing that, we can see that ABD and CBD equal 180, and we can substitute knowing that we have 100 degrees here and 80 degrees on this side. So angle ABD, or triangle ABD, must be an acute triangle by definition. We look at some triangle classification by side lengths. Equilateral triangle means that we have three congruent sides. And you can see that the hash marks or the tick marks are represented for each side to let you know that they are all congruent. An isosceles triangle has at least two congruent sides. You can see that they're labeled. A scalene triangle has no congruent sides. So we have three different measures for each of the three sides. Remember, when you look at a figure, you cannot assume the segments are congruent based on appearance. Even though they may look alike, you got to make sure that they're marked with congruent marks. So, we're going to use this information to look at how do we classify triangles by the side lengths. So we're given EHF, triangle EHF, and they want to classify that by its side lengths. So the first thing I have to do is make sure that I understand which of the triangles we're looking at. So we're looking at EHF, so this triangle here, in terms of that part of it. So we have a measurement of 12, a measurement of 10, and then we don't know what this measurement is. But what we can see is that we've identified it with a tick mark. So we can see that it's congruent to the measurement that's below. So EF and HF are congruent, so HF is 10, so EHF is isosceles because we have two sides of the same. So this is a 10 and this is a 10. We're going to look at triangle EHG, and again we're going to label it by its side length. So EHG, so the entire larger triangle. We see that we have a side measure of 12, a side of 11, and then when we put 10 and 4 together, we can see that we have a side of 14. So we have three sides with three different measures. By the segment addition postulate, we know that EG equals EF plus FG, so the 10 plus 4. So we get that as 14. Since none of the sides are congruent, we can say that this is a scalene triangle. And again, we're looking at it in terms of algebraically. Now we're given to find the side lengths of triangle JKL. Knowing that these two equal each other, we can see that with the congruent marks, we're going to go ahead and set up a algebraic problem so that we can solve it. First thing we know that we have JK is congruent to KL, so that means they must be equal by the definition of congruent segments. So we're going to substitute our values in, 4x minus 10.7, and we're going to make that equal to 2x plus 6.3. Then we're going to go ahead and solve to get x by itself. So the first step we're going to do is add 10.7 to each side so that we get 4x on this side, and then when we add it over here, we're going to get 2x plus 17, so we're going to subtract 2x from each side, and we're left with 2x equals 17. Divide both sides by 2 to get x by itself, and we get x equals 8.5. So we're finding the value of x, which is our first step, but now we have to substitute that back in for each of the side measurements to get the side lengths. So 4x minus 10.7, we're going to substitute 8.5 in and solve, and we get 23.3 for our measurement of JK. Substitute 8.5 in the 2x plus 6.3, and we get, again, 23.3. Since those are congruent, that makes sense that they're both the same. And then our last side, 5x plus 2, we substitute it in and we get 44.5. So we're able to, again, see what each side measurement is. Hopefully that will help you in solving or working on these 4 problems. This is what I'd like you to complete for tonight. Gives you a quick video here, overview of how to solve each of these. There's 4 questions. The first 3 ask you to classify each triangle by its angles and its side measurement, so you should have 2 answers for each of these first 3. And number 4 asks you to find the side lengths for each of the triangles.